talking about the low voltage diagram. Here we have all of the relays in place. We have our transformer, heat sequencer, compressor contactor, reversing valve, fan relay, and thermostat. Let's hook this bad boy up, put it all together. We'll start with the transformer. We know that the primary side needs 240 volts. We're going to go up to L1 and L2, 120 apiece. We're going to bring L2 down, make a connection here, bring L1 down, make a connection right here. That's giving us 240 volts on the primary side of the transformer. What do we get? We get 24 volts on the secondary side. 12 volt common and 12 volt control. Now we've been talking about 12 volt common blue, 12 volt common blue. Let's see how that all ties in. So we're gonna go with the blue line right here, coming off our 12 volt common. And let's look at our relays. Heat sequencer, low voltage has 2 legs. Compressor contactor, low voltage has 2 legs. Fan relay, low voltage has 2 legs. Reversing valve, low voltage has 2 legs. Every relay has 2 hands of low voltage. 2 hands of low voltage. So number 1 rule is put the common in my hand. Every single one of these relays demands 12 volt common from this transformer. So the first thing we're going to do is put the common in my hand. We take our blue, we're going to run 12 volts up to 12 volt common on the heat sequencer. We're going to take this common and we're going to run it 12 volt common on the compressor contactor. We're going to take this fan relay, take our 12 volt common, and it also is going to go to 12 volt common blue. Reversing valve, no different. We're going to take this common down, bring another one out, and drop down to the 12 volt common leg. As we see here, when I say 12 volt common, I keep saying common, 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 because every relay has 2 hands, and you put the common in my hand. Don't play with the common. When it comes to these relays, do not play with the 12 volt common. Every single relay is going to get 12 volt common along one leg. Mandatory, every time. Every single time. What this does is this basically puts 12 volts at every relay at all times. Now, what did we discuss for 12 volt control? 12 volt control is our red. It comes out of the secondary side of our transformer, drops down, and feeds into the red for the thermostat. Okay, so now we have every relay has 12 volt common in one hand. Let's fill the other hand with the control. So we have 12 volts coming here into the thermostat. We'll start with green. Through the SurveyMonkeys, we've learned that the relay gets the green wire. What do we mean? That means that your thermostat has a green leg right here. So what we're going to do is we're going to take this green, we're going to drop it down, we're going to go around, straight up, and over to the fan relay. So 12 volts is going through the thermostat. The thermostat says, hey, it's hot in here, turn on the indoor fan. Then the thermostat will jump this 12 volts from the red into the green. 12 volts will travel down the green to the fan relay. Now the fan relay has its 24 volts. It will continue this circuit so the fan motor can turn on. What's our next one? We're going to go with yellow. Our compressor contactor, all the way out here. So we need to get 12 volts on the yellow. Compressor contactor gets the yellow. So yellow is going to drop down here. Don't forget our bridge, half moon bridge, to show that we're jumping a wire. Go all the way around, all the way up, all the way over. And now yellow is going and energizing the control side of our compressor contactor. Reversing valve. The reversing valve is what makes heat pump possible. it's switching it from heating to cooling. And this is controlled by the orange. Reversing valve gets the orange wire. So then orange will come down from orange. Looks like we're gonna be able to make a right, jump it, very good, bring it over, and then up. There's your orange wire. So now, when Mr. Thermostat says, hey, turn on to heat pump mode or turn off heat pump mode, it'll energize the voltage through the orange wire, and now the reversing valve will have its 24 volts. We have one more for white. White is very difficult to see here, so in white, we're gonna use purple. So that way we know that purple equals white. Now, you should be able to do this just with a pen, a black pen, and then, put write down orange, write down yellow. But to help us learn, we're going to use colors. So our purple is our white. So let's get our white down here. We're going to jump the bridge again, bring it back over. We got to go up to here to the heat sequencer, jump the bridge again, and then we're going to travel on up. Jump the bridge again, over, one more bridge, over, and we're gonna land on the heat sequencer. Our purple is our white. So what do we see here? We can agree that every single relay, whether it's the fan relay, the heat sequencer, the compressor contactor, or the reversing valve, all have a common leg. Common leg always goes to the blue common on the transformer. Put the common in my hand. This 12 volt is owed by the transformer to every single relay. So when you see all these wires, you think, oh wow, that's a lot of wires. Well, no, we break it down. There's a common, 12 volt common, 12 volt common, 12 volt common, 12 volt common. Common is blue. Put the common in my hand. Put the common in my hand. So every relay has its 12 volt common in its hand. Next thing, bring over the control, which are the color wires, the thermostat wires. So 12 volt at every relay uninterrupted. 12 volt control is going into the thermostat. So now what happens is when the thermostat says, hey, we need air conditioning, the red will send 12 volts to the green because that's the indoor fan motor, and it'll send 12 volts into yellow because that's gonna send, that 12 volts is gonna go through the green, turn on Mr. Fan. It's gonna go through the yellow and turn on Mr. Contactor. So now the condensing unit's on, the indoor fan motor's on, now we're cooling. Okay, wait, now we need heating. So when we need heating, we're not gonna use yellow anymore. We're still gonna use green, and the red is gonna use white because white is going to activate the heat sequencer and turn everything on. So that leaves us one last terminal on the thermostat, and the color is C. So if anyone can guess what the C means, it absolutely means common. Even the thermostat will get common. The thermostat will get 24 volts from the transformer. If you look at many thermostats, it says C is optional with batteries, meaning if there's batteries in the thermostat, then you don't need a common wire. But the higher end thermostats that have no batteries, have to have a common. So how do we do that? Is there's another common that leaves here, goes back here, and also ties in with common. So your thermostat will get 24 volts. It'll get 12 volts here, and then it would also get its 12 volts on its red side. And that's how our thermostat gets 24 volts. But just keep in mind, this red will never jump to the common. It would only jump to the green for the fan, yellow for the compressor contactor, white for the heat strips, or orange for the reversing valve. This is our low voltage diagram. As we can see, everything starts with L1 120 volts, L2 120 volts, feeding the primary side of the transformer 240. Mr. Transformer says, thank you, you've given me my 240, now I'm gonna give you your 24 volts. I'm gonna give you 12 volts on the common side, and I'll give you 12 volts on the control. From there, the relays each say to the transformer, put the common in my hand. And the common will leave the common side 12 volts, feed half of the heat sequencer, half of the fan relay, half of the contactor, half of the reversing valve. These blue wires never go away. It's only the control, the other 12 volts, that is manipulated by the thermostat to give it the other 12 volts for it to start, for it to close. What a relay does is it takes low voltage and then it opens a channel, either to turn on a fan relay, to turn on heat strips, to turn on the compressor, to turn on or to engage a reversing valve. That's what low voltage is. It's us controlling high voltage with just 12 volts of low voltage through a thermostat. If we didn't have low voltage, what that means is there would be 120 volts going through your thermostat to try to control everything in the air conditioner, and homeowners would electrocute themselves. That's why we use a step-down transformer to get ourselves down to 24 volts, make sure every relay has the common in my hand. I cannot stress it enough. Put the common in my hand. Every relay gets its 12 volt common. And then the control goes through the thermostat, and then to the green wire, yellow to the contactor, white to the heat sequencer, orange to the reversing valve, and there's always a gap there in C for 12 more volts, so to make sure the thermostat has 24 volts. This is the low voltage relay. We're gonna do it over and over and over again, but you have to understand, every single relay has 12 volt common in my hand. And then all the colors we talk about leave the thermostat to give it the other 12 volts to complete the 24 volts. And this is why I say common and control are so necessary to understand, because I could put 20 relays on this board. And if I put 20 relays on this board, we know each relay has 2 hands of low voltage, here and here, here and here, here and here, here and here. If I put 20 relays, you know that's 10 hands that are each gonna get 12 volts common. Nothing changes this. Every air conditioner that you come across is gonna be wired with the same controls. Absolutely, especially residential. 12 volt common, 12 volt common, 12 volt common, 12 volt common. Put the common in my hand. All right, now let's move on to how we incorporate the actual fan motor, the actual heating elements, the compressor and the compressor fan, and the reversing valve itself. Hang in there, it's speeding up, you guys are doing great.